S-Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, as we have discussed about the microprocessor shift registers, so in this video we will discuss about the basic elements of the digital communication and how they are important.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
So welcome to the S-Chan Academy, and my name is Kanhaiya Jha. Today we will discuss about the elements of the communication system, that how a signal is processed from the one particular point to another particular point, and then how it is absorbed at another point. We will discuss all the things today. We will discuss about the input message. After the input message is given, then the input transducer, then it goes to a transmitter, then the channel, then the receiver, and the output. Basically, we have a lot of things to discuss in this particular communication channel. Let's take a very small example from day-to-day life, and that example is, we'll discuss here, that what happens when someone calls from the landline phone and someone calls from the mobile phone. What is the difference? How the communication is different in both the particular mode. So let's discuss this. So let's say that this is the port A, and which is calling the port B. A is calling B on a landline phone. So the first A call will go to his local exchange, and then it go to his main exchange, then it will go to the B call, local exchange, and then to B, if this is a local call. If we are doing this call from one city to another, then there will be one more exchange added, the local exchange of them. If we are making an international call, then again one more exchange will add, the exchange of the particular country. So we can see here that depending upon the particular length of the communication, the exchanges are added. And the major drawback here is that if any of this exchange stops working, the entire communication is stopped. From this particular exchange, if any of the exchange stops working. So to work it out, what we have designed, we designed the system called FEP. FEP is basically the front end processing. In the front end processing, what we generally do is, this is the front end, and these are all the users that we have. So suppose this is A and this is B, and the A wants to call B. This is C, D, E, all the particular users. So if A wants to call B, the call will go to this exchange and come to him. If A wants to call E, again the call will be routed directly. So we can see the difference here, that in the first case, the number of exchanges were increasing, and due to the increase in the number of exchanges, then the communication was very slow. The communication was very slow. Here, this is the front end processing here. So the call will be directly routed to the desired person in the mobile communication. So in this particular slide, we will learn that how it is done, what are different technology and the different terms which are used when we are doing this particular communication. So first one is a transducer. Transducer is basically which converts the message into the particular type of the communication system. Like basically we say that transducer generally convert the message into the electrical signals. That whatever the message that we get, okay, that generally converts into the electrical signals. Why it converts into the electrical signals? Because the machine can only read the electrical signals. So when the electrical signals are processed from the particular machine, then we get a particular output. So the machines, the particular messages are sent, then we get the particular output from the particular machine. Then we have a transmitter. The transmitter processes the input, and they process the input, and then we get a particular desired output. For example, modulation, oscillation, amplification. These are some examples that can be done with a particular transmitter, that we are using the transmitter that will generally modulate the particular signal if required. Modulation can be done at any part. Modulation can be done in terms of the amplitude. The modulation can be done in terms of the frequency. The modulation can be done in terms of the phase. Modulation can be done in terms of time, in terms of duration and everything. So, this particular transmission can do with this. Then with a transmission medium, that medium is basically designed that how the medium is used. Either we are using coaxial cable, we are using the optical fiber, or we are using the ground wave communication, or we are using the sky wave communication, or we are using multiple communications and all. So, here we have two main categories of the channel commonly used. The first one is a line. Line communication, as the name suggests, is a wired communication. Wired in the sense that the two ports will be connected with a cable. And then free space radiated media is basically when they are not connected with the cable. So, what is there is some limitation when we say the ground communication or the line communication. The limitation is that depending upon the wire, depending upon the nature of the wire, this range can be defined. This range always use the wire, so the cost is high, and then the the particular condition for a distortion is very high because the wire can be breaked at any time. So, we discuss this in terms of when we take this particular communication with a radio wave on a low frequency, and then we name this as a space communication or a space media communication. So, in this we do not use the wire, and when we do not use the wire, then particular communication is done with a space communication. Then we have the receiver. Receiver in the end receives the particular signal that was sent. When it receives the signal, again there is a transducer. Then again it will check the particular wave, that if any rectification is required or the wave is proper. So, we are using a transducer at both the part. One is the input, one is the output. So, what we do in the input is we change the original message to the particular electrical form that passes through the electrical network, and then it can process it. When it processes it and goes to the receiver, again a transducer is used, and that particular transducer translates the electrical signal into the original message. The first, we translate the original signal into the electrical signal, and in the output what we do is we convert the particular electrical signal into the original message. So, we send original message, and in the output we are getting the same message as we have proceeded with this. Then there is a spectrum. The spectrum is basically a range which can generally say that either we are using the VLF is a very low frequency, then we have LF, which is a low frequency, then we have HF, high frequency, then VHF is a very high frequency, UHF is ultra high frequency, and then MHF is the mega high frequency. So, depending upon the frequency that we are using, depending upon the particular propagation that we are using, when the communication will travel from the one particular signal to the another signal. So, we can see here that spectrum is the particular range. Then we have this electromagnetic waves. Electromagnetic waves are basically a sinusoidal propagation. As we can see here, this propagation is a sinusoidal propagation, that we are using the sine wave, the electric wave and the magnetic wave, which are sinusoidal to each other or which are perpendicular to each other, and they propagate. Let us discuss this electromagnetic wave, that we are discussing all the propagation. So, this is the this is the one particular wave. So, this is, if this is E, This is be the magnetic. One is the electric, one is the magnetic. So one is the electric, one is a magnetic. Again, one is the electric, one is a magnetic, like this. Right. So the one is the electric and one is a magnetic. So the electric wave and the magnetic wave, they are perpendicular to each other. So what we do is that we make a particular circuit, and the propagation, that the nature of the wave used is the electromagnetic wave. So electromagnetic waves are generally sent from one particular part to another particular part. So we can see here, as we can see in this particular diagram also, that E and B are perpendicular to each other. So here also we can see that E and B are perpendicular to each other. So the type of the propagation, type of the wave we want is a electromagnetic wave, and the nature of the particular movement is a sinusoidal propagation. Then we have the frequency. Frequency as such, that is number of times the wave passes through the mean point. It's very easy to remember, that we can say that this is the mean point and this is the wave coming and going from the mean point. So we can say that a frequency, in a very simple term, that a number of the rotation per unit time, or number of rotation in 1 second. So we can say that a number of rotation taking place in 1 second, or a number of rotation taking place in 1 second. So we have here frequency. As you can see that this is a particular mean point, and from the mean point the variation is occurring. From the particular mean point the variation is occurring. So we can say that how the wave is going up and how the wave is coming down, and then we calculate the particular variation from the mean point. So we calculate the variation from the mean point, and then number of cycles taking place in a particular interval of time. Then we have the other parts of the communication system, but in this part basically what we learn is what are the different parts. As we have discussed that transducers are used in the input and it was used in the output also. First we translate the original signal into electrical signal, and in the second case we translate the electrical signal to the original signal. So in the end what we are getting is the original signal, only the processing is taking place. We have discussed the type of the signal used, electromagnetic waves, and how they are propagated. Now we'll take a small break and then we'll discuss further. Thank you.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
So students, welcome back. So before the break we have learned about the different terms that we are using in the communication system. So we have learned about the particular frequency, that this is 1 kilohertz as 1000 hertz. Then again 1000 kilohertz is a 1 megahertz. Then 1000 megahertz is 1 gigahertz. Then 1000 gigahertz is 1 terahertz, and then 1000 terahertz is 1 peta, and then 1000 peta is 1 exa. So these are the particular variation. So we have, as we have discussed in the before the break, we have very low frequency, then medium frequency, high frequency, very high frequency, ultra high frequencies, super high frequency. So this particular frequency range is given. You might have seen that either you are using a radio set or you are using the television channel and the other things. The frequency set is given to you, that how to calculate the frequency set of this, how the different frequencies are given to us, and then depending upon the frequencies we are calculating the particular variation. So here we can see that the very low frequency 10 hertz. So you can see that in the radio some channels are available on a very low frequency and some are very high frequency. In the television also some channels are on a very low frequency, they are available on a very low frequency, but some are at a very high frequency. So bandwidth we are talking about 50 Mbps, then 200 Mbps, then 500 Mbps. So depending upon the particular nature of the message they are carrying. Again, coming back to the topic of the transducer, converting the signal into electrical signal, these things generally matters, that what is the nature of wave, what is the nature of propagation, what is the frequency taken. We cannot take every wave to every particular frequency. Depending upon the nature of the wave and depending upon the nature of the frequency that we set. Either we are setting the frequency on the lower mode, we are setting the frequency on the higher mode, or in a very higher mode, this particular bandwidth will generally matter. Then we have wavelength. Wavelength is denoted by lambda. Here we can see that denoted by lambda. Okay, and it is a distance between the similar points of the back-to-back waves. So similar points you can see here from back-to-back waves. So here again we can see, make one thing and understand here that this is the wave. So this distance is a wavelength and this distance is the amplitude. We can say that the positive axis and the negative axis, see the x-axis and the y-axis. On the x-axis we have a wavelength, the variation, and on the y-axis we have an amplitude. So we have the two things, the x-axis and the y-axis. On the x-axis we have a particular wavelength, and on the y-axis we have a particular frequencies. Phase depends upon that, either in the upper part or the lower part here, how the signal is generally varying. Either the signal is varying on the upper part or the signal is varying on the lower part of the particular mean point. So depending upon the upper part and the lower part of the particular mean point, we are calculating the variation. So this is basically that the phase, the two waves can be said to be in the same phase when they are varying with the same frequency and they are varying in the same medium with the same wavelength. So they are said to be in the same phase. We can another study here that this wave A and this wave B, they are in the same phase, but here, so we say that A, B and C. So A and B here are in the same phase and the A and C are out of phase. A and B are in the same phase and the A and C are out of phase. This is what we need to understand in this. Then we have phase, we have already discussed, either the upper part or the lower part of the particular channel. Then we have effect shifts, that how the wave generally vary. When the wave generally vary, then we can see that there is a change in the particular wavelength. We start with the initial wavelength and then the changes occurs in the wavelength. As the signal proceeds, then the changes occurs in the particular wavelength. So as the signal, as we can see that it is processing, then we are observing the changes with a particular wavelength. Then the frequency will also change, the time period will also change, and the time period is 1 by f. So we can anytime with if any particular calculation that we want to do, either the wavelength, either the time period or the frequency, phase, initial wavelength, we can do with a particular wave. We can see here that from the particular phase, then there is a wavelength. We can see here the wavelength, the amplitude, and then we can also see that how the calculations can be done. So when we say a particular wave, then we need to understand that that wave must have a particular phase, that when it is going to and fro from the mean point, then it has a wavelength also. Then when it is a wavelength, then we can calculate the frequency, and from the given frequency we can calculate the particular time period also. So these are the calculations that we can do with a particular wave. So in normal operations, we are taking the electromagnetic wave, and the nature of the propagation is a sinusoidal when it passes from the one particular machine to the another particular machine. When it is passing from the one particular machine to the another particular machine, then this EMW is taken. In that EMW also, we can calculate either the input and output are in the same phase, or the input and the output are out of phase, or we can see that we can calculate the wavelength, we can calculate the frequency, we can calculate the time period, everything of that particular wave we can easily calculate either from the time period or from the frequency. Some basics of the communication that we have, this is the propagation that we study. Then amplitude, we have already discussed that the variation between the top cycle and the bottom cycle. The variation between the top cycle and the bottom cycle is generally calculated as an amplitude. So these are called as a crest and the trough also. So we have learned that what are the basic parts of the communication system. The first we have learned in the communication channel how the number of exchange generally matters. If the number of exchanges are high, then what is the risk factor? We have discussed the front end processing, that all the particular exchange are generally working with a single particular exchange, then what is the plus point? How the communication is done fast. Then we have discussed that transducers are used in the input and they are used in the output. So what is the role of converting the original message to the electrical signal, and then again the electrical signal to the original message? We have discussed about the wave. We have discussed that how electromagnetic waves are used for a sinusoidal propagation. What is the amplitude? What is the frequency? What is the phase? What is the frequency? What is the number of rotation from the mean point? That generally matters. And how we can analyze the input and output when they are varying in the same phase, and how input and output when they are moving out of phase. So hope you have enjoyed this video, which teaches you about the basics of the communication systems with the different terms. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.